Question 4. An investment of $1,000 was made in a certain account and earned interest that was compounded annually. The annual interest rate was fixed for the duration of the investment, and after 6 years, the $1,000 increased to $4,000 by earning interest. In how many years after the initial investment was made would the $1,000 have increased to $16,000 by earning interest at that rate? Well, at the beginning, we are given a situation of compound interest calculation. We have a principal of $1,000. We have an interest rate which is unknown, but is an annual interest rate. Let's call it X%. And the duration of the investment was 6 years. So, since we have the 3 elements, we can see that the multiplication of the 3, that is 1,000 times 1 plus the interest rate up to the duration of the investment should yield the total balance, which is $4,000. Then we are requested to find how many years, let's say a number of years n, should pass for the $1,000 to have increased to $16,000 by earning interest at the same rate. So, in another situation, we have $1,000 times 1 plus the same annual interest of X% up to a duration of the investment which we want to determine n years, in order that the total balance after these n years have passed equals $16,000. So it's basically determining n, knowing that we have this information about x. Okay, first of all, in these two equalities, we can get rid of the thousands, simplify the expression. The first equation would be 1 plus x over 100 up to 6 equals 4. And we can use this information in order to determine the value of n. Instead of isolating x and replacing in the second equation, we can use the expression as a whole here, this power with a 6th exponent, to calculate n. We can use the properties of powers and exponents to express this power here, 1 plus x over 100 up to n, as a power of a power, in which the original base is this power, and we raise this power to a certain exponent, n over 6. But we know that the value of what is in the square brackets is 4. So this equals 4 up to n over 6. While on the right side of the equality we have 16, which we can represent as the square of 4. So there is another property that says that if we have two powers of the same base having the same value, that is, the two powers are equal, then the two exponents must be the same. So n over 6 must be 2 and n should be 12. And the answer to the question is option B.